Active transport is the movement of molecules from a region of low concentration to a region of high concentration, in other words, against the concentration gradient. And therefore the process requires energy in the form of ATP, and the molecules are going to move via a protein pump in the membrane. So let's look at the sodium-potassium pump in a little more detail. The role of this pump is to move sodium ions from the cytoplasm where they're at a low concentration to the extracellular fluid where they're at a higher concentration. The potassium ions are then moved from the extracellular fluid to the cytoplasm against their own concentration gradient. To achieve this, firstly, the sodium ions bind to the protein pump. ATP then binds to the protein pump. This is converted from ATP to ADP. The breaking off of the phosphate from ATP provides the energy for the conformational shape change of the protein. This allows the sodium ions to pass into the extracellular fluid. The potassium ions then bind to the protein pump once the sodium ions have been released. The binding of the potassium ions to the protein pump results in a conformational shape change, which allows the phosphate group previously bound to be released. This allows for the release of the potassium ions into the cytoplasm and the return of the protein to its original shape so the process can repeat itself. Finally, in summary, active transport requires a protein pump, and this changes shape and therefore requires energy in the form of ATP. Active transport moves molecules against their concentration gradient from a region of low concentration to a region of high concentration.